All right, good morning, everybody. So we're picking up at where we left off in this string lecture. So remember, in Java, a string is a sequence of characters. And in Java, just like in Python, strings are immutable. So you cannot change the sequence of characters once you create it. If you want a different string, you have to make a new string object. So strings have many methods. So when we looked at the documentation in the last class, you saw that the document describing what methods a string has is very long. To effectively use the string class, you need to be aware of what it can do. But obviously, I don't have time to cover every method that a string has. We'd be here for several days, which isn't really worth our time. So I'm only going to highlight the ones that are very commonly used. The contains method lets you test if a string contains a substring. Right? So does sysc124 contain the string all caps sysc? Right? And so that method is contains. Right? It's a non-static method, so you need to use a string variable or a string reference to call the method. Right? So here I can ask if the string course name contains the string all caps CISC. The answer is true in this case, right? Because the sequence CISC appears in the course name sysc124. Right? Case is important. So if you ask, does sysc124 contain little CISC, the answer is false. Right? Does it contain the 4? The answer is true. Right? You can't pass in just the regular number 4 here, though. So you can't write course contains and then the digit 4. Right? There is no method that tests whether or not an int is inside of a string. Right? You need to ask, is a string inside of a string? And even that's not quite true. So let's go look at the documentation for contains. All right, so this is the string documentation. If you look up contains, right, what you'll find is that its parameter type is in fact not a string. Right? So it's something called a car sequence, and we haven't seen a car sequence yet. Right? So this is an example of what's called inheritance in Java, and it also exists in Python. So in an object-oriented language like Java, some types are substitutable for other types. And so we're going to see this, we're going to study this in detail, probably in like week 8 or 7 of the course. Right? But this is the first time that we've run into this thing. So if you click on car sequence, it takes you to here. Right? And if you look at the car sequence documentation, it says a car sequence is a readable sequence of car values, which sounds a lot like a string. Right? If you look up here, you'll see this section called all known implementing classes. Right? And you'll see that string is one of those classes. So what this is trying to tell you is string is in fact a car sequence. Right? And if you go back to the string documentation itself, I'll go all the way to the top, right? Here it is, right? Up here you see there's the name string. You also see up here there's something called object, and we'll talk about that in a couple of lectures. Here you'll see a section, all implemented interfaces, and there's car sequence. And if you read all of this down here, right, you'll also notice that car sequence is one of the things mentioned when you declare the class string, or when the class string was declared. So what this is trying to tell you is that a string is not just a string. Right? So in Java, a string is a string. It's also an object. It's also this thing called serializable. It's also this thing called comparable string. And it's also this thing called car sequence. So reference types in Java, they all have more than one type. Right? They all have multiple types. So a string isn't just a string, it's multiple kinds of things. And we'll talk about this in greater detail later on. But the fact that a string is also a car sequence means that when you use contains, right, even though contain says it takes in a car sequence, that means you can also pass in a string, right? Because a string is also a car sequence. Right. Okay, so that's all a little abstract for the time being, right? It's actually talking about a fairly an advanced object-oriented concept, right? But I thought it's important to point out to you what's going on here so that you don't get too confused if you actually do read the documentation and wonder why can I pass in a string if contain says it takes in a char sequence. So contains, test of a string contains another substring is the best way to think about it. Notice there's no version of contains here that takes in an int or a char. So if you try to pass in a char like this, you get an error. Right? So it turns out you cannot test if a string contains an individual character. You can only test if a string contains a substring. So if you want, does it contain the letter C, you have to turn the C into a string. The easiest way to do that is via string concatenation. Right? Take the empty string, add C to it, and that will now work. Right? The better way to do this, though, is to use a method that actually tests if a string contains a char. Right? And so that's the methods, those are the methods that start with index, that have the word, the two words index of in them. So index of is the method that you should be using to test if a string contains a particular char. Right? Index of tells you where is the index of that character in the string. Right? If it's not in the string, you get back -1. So here's our string sys124. Right? And we can ask where is the first occurrence of the capital letter C. Right? So course name dot index of. Right? We want to remember what that value is, so we store it in a variable called index. Right? And if you print it out, you get 0, right? Because the capital C is the first character in sys124. Right? So we can ask where is the location of the S, right? And then print that out. So that turns out to be 2, right? It's the third character in the string, so it's at index 2. Right? Where is the character 4, right? Not the digit 4, but the character 4. Right? And so that's the last position in the string, which turns out to be position 6, right? It's the 7th character in the string. And if you ask where is the Z or any other character that's not in the string, you get back -1. So you can use index of to test if a string contains a character, and look to see if the value returned by index 1, index of is equal to -1. If it's negative, it's not in the string. Last index of finds the location of the last occurrence of the character. Right? So index of, first occurrence, last index of, last occurrence. So where is the last C? Well, it's at 0, 1, 2, sorry. Oh, sorry. Right. Where is the last C occur in sys124? Well, it's the 4th character in the string, so it occurs at index 3. Right? All of the other examples are the same. Right? There's only one S, so its last occurrence is at index 2. There's only one 4, its last occurrence is at index 6. There is no Z, so its occurrence doesn't. So last index of returns -1. Okay, equals is confusing in Java. Especially for programmers coming from Python or for new programmers in general. Java is inconsistent in how, in its treatment of how do you test if two things are equal. Right? Okay, so if you want to test if two strings are equal, so do they have the exact same sequence of characters and do they have the same number of characters? The method that you must use or should use is equals. Right? Now this is confusing because if you want to test if two primitive values are equal, right, you always use equals equals, and if you want to test if two primitive values are not equals, you always use exclamation mark equals, right? So remember, Java has this operator equals equals. It has the operator exclamation mark equals for not equals. Right? You should only use those operators when you're testing whether or not two primitive types have the same value. Right? If you want to ask the question, do two reference types have the same? Are two reference types equal? You should always use the equals method. The problem is equals equals and not equals also works, quote unquote works, with reference types, but the meaning is very specific. Okay, so here I have sys124 and math124, right? Are those two strings equal? Well, no. They have the same length, but they have a different sequence of characters, so that's false. Is sys124 equal to sys124? The answer would be yes. They have the same sequence of characters. Their lengths are equal. Right? Is math124 equal to math124? The answer would be yes. Right? Here, case matters again. right? So if you want to test, so is that string equal to that string? The answer is no, right? So you get back false again. So let's go and look at Eclipse. So I'm going to expand on this idea of can you test if two strings are equal using equals equals. So here I've got the string hello, right? It's stored in my variable s. I'm going to make another string here, hi. And I'm going to say that's equal to hello, right? So it looks like those two strings are equal, right? So what happens if I write what if I write s equals hi, like that? Let me comment out the next two lines of code. Okay, so I'm going to use equals just like I showed you how to do in the slide. I'm going to run it. It says true, they're equal, right? So that's great. So if you remember that you should always use equals when comparing strings for equality, good for you, right? Now the problem is that many programmers new to the language will remember that there is this operator equals equals, and they will write the following, right? They'll run their code, and guess what? It also says true, right? And if you change one of the two strings, so let me make h big H, right, and run that, right? It now prints false. And so the impression that the new Java programmer gets here is that, well, you can just use equals equals for strings and everything works just fine, right? And in fact, it's possible to write an entire program or a body of code where you always use equals equals or not equals with strings, and it always seems to work, right? The problem occurs when it doesn't work anymore. So here, I've got this method called join, right? And so join does exactly what you think it does. It takes this string, concatenates it with the next string, right? So up here is join s and t. So I just add s and t together, right? Perform string concatenation and return the result, right? So this should be the string hello. I guess we should check. So let me comment out this line so we don't get too much output. Okay, so it looks like when I print out t, it's H-E-L-L-O, right? If I were to print out s, it's also going to be, not surprisingly, H-E-L-L-O. Now when I ask, hey, are those two strings equal, it says false, right? And so that's the problem. You can compute a string that is equal to another string, but equals equals will tell you they are not in fact equals. Equals will always tell you whether or not two strings have the same length and contain the same sequence of characters. Right? So that always works. So don't use equals equals to compare two strings for equality, right? It doesn't mean what you think it means. Yes? Well, equals returns true or false. So you just write. Here, let me show you. It's a good question. So like that, right? Equals returns true or false, right? So you can use the result of equals as a condition, right? Run that, it's going to say s is equal to t, right? And if you can do the same thing with equals equals, right? So if s equals t. So I'm going to change what it outputs here. Oh, sorry. Control Z. Okay, so instead of writing s is equal to t, I'm going to write s is like that. Okay, so now it does not print s is the same object as t, right? If I change t to hi, What happened here? Oh wait, I can't. S. Did I do something strange? That should. Oh wait, I changed. Haha. Sorry, case problem. There we go. There we go. Okay, so S is the same object as high. So what equals equals is actually doing, it's testing, are the two objects, do the two variables refer to the same object? Right? And so that's what, so there was a slide in the previous lecture that said the language tries very hard to make string behave like a primitive type. It's not, it's still a reference type. So what the string class is doing is that if you use the same literal in your program more than once, right? So there's the string literal hello, there's the string literal hello, right? The string class doesn't store two instances of the string hello, right? So in other words, it doesn't make two separate objects. It makes one, right? Because it remembers what string literals are actually in your program, right? If you use the same literal over and over and over again, it doesn't make sense to have a separate copy of that object in memory over and over and over again, right? You can't change the letters in the string, so it makes sense if you only keep one copy of that thing around, right? And it tries very hard to do this, right? And so when you write that, you're asking, are S and high, do they refer to the same object? And the answer in this case is yes, right? They're both the literal hello, right? It actually goes further than this, right? So the language tries very hard to make sure this is true, right? If I compute the string high as HEL plus LO, right? The language is smart enough to know, or the compiler is smart enough to figure out that in fact you have the same literal again, right? So it still prints out S is the same object as high, right? Which is super confusing, right? Notice that when I call join, right? Join does the same thing, right? It does HEL plus LO, right? The difference here, though, is that you're passing in two different strings, right, to a method up here, right? So if you try to call a method, then the compiler doesn't try to figure out whether or not the result of the method is in fact the same as one of the literals in your program, right? So if you write down that, right, the compiler chugs, it computes HEL plus LO, sticks it together and says that's the same as hello, right? And so S and high are the same object, right? Let me change this to T again. Right? So as soon as you call a method and you're asking the method to compute something with the arguments passed to the method, then the compiler no longer tries to do this optimization, right? And so here you get S is not equal to T, right? So if you want to test if two strings are equal, use equals, right? If you want to test if they're not equals, use not equals, right? So if not, S equals T, right? S is not equal to T. So let me change T like that, right? And so now we get S is not equals to T, right? So yeah, so the fact that there are two different ways to test for equality in Java is very confusing to almost every new programmer, right? This is not what you expect to happen, right? So the rule is, if you want to test if two reference types are equal, use dot equals. If you want to test if two primitive types are equals, you can only use equals equals, right? There is no equals method for primitive types. Later when we start to talk about objects, we'll revisit exactly what this does. All right, any questions about equals? For now, everything's good if you just remember use dot equals if you're testing strings for equality. Oh, I guess I should mention, if you want to test if two arrays are equals, you can't use dot equals, right? So that's confusing, even more confusing, right? So if you want to test if two arrays are equals, you have to call a method of some kind, or you have to write your own loop. Right? Okay, the plus operator we've seen, it does string concatenation, right? So a string plus anything always results in string concatenation. The order matters, though. So here's James Bond 007, right? name2 is James space plus bond space plus 007, right? Are those two things the same, so are those two strings equal? The answer is yes, right? So is name1 equal to name2? The answer is true, right? So take the string James with the space, join it with bond, followed by a space, join that with 007. You can concatenate anything to a string, right? So here's here, James Bond space, then +0 +0 +7 works just fine, right? What the language does here is it looks at this argument here, right? It says it's a string, so as soon as you write string plus anything, it takes the anything, converts it to a string, and joins it together using concatenation. Right? So this expression here, notice there's plus, plus, and plus. So you have 3 instances of the plus operator. So Java in this case goes left to right. Right? So it computes James Bond +0, so that's James Bond space 0. Right? That all results in a string. So it's now string plus another 0, so that's the string. Join it with add another 0 to the end. That's all the string, right? And so now string plus 7, it gives you James Bond 007. So it goes left to right. It ends up computing 1, right? Then 2, and then 3 strings to compute the result. Right? So that's exactly what is happening, right? So James Bond +0, that results in 1 new string object, right? That result +0 results in a second new string object, and then all of that +7 results in the final string object, right? You might ask, so where did those 2 intermediate objects go? Right? And so the answer is it's probably still somewhere in memory. Eventually, the virtual machine will decide that, hey, I don't actually need this string, so it will get rid of it and free up the memory that's occupied by that string. Okay, so you have to be careful about how Java evaluates expressions, though. Right? So I told you string anything gives you a string, but remember when right, plus and plus, and what order is it going to evaluate this expression in? So it's all plus, so that means the precedence of all the operators is the same, so it's going to go left to right. Now it sees car plus car, right? So when you have 2 cars together, something, and it converts everything to int. Converts the A to an int, right? Now you have an int, right? Int plus a string, now that's string concatenation. So now you get a int plus HA. And so the result that you get is 201A, right? Which is really good, right? You started with 2 cars and you ended up with an int, right? Whereas what you probably wanted was ha-ha. And so this doesn't work, right? So the order in which you write things can matter. The easiest way to fix this problem is to start with the empty string at the front, right? Because the empty string, if you put it at the front and concatenate that with anything, will always result in a string being computed in the end. Right? So if you wrote empty string plus H plus A plus HA, everything would be fine. Right? A cast here doesn't work. So occasionally, I will see a student try to cast a car to a string. That doesn't work. Right? You can't convert a primitive value to a string using a cast. Right? Primitive value to a string, the empty string and concatenate value. Okay, you can slice a string in Python using Python's slice notation, right? Because Python treats all sequences the same way, right? And a string in Python is just a sequence of characters. So you can slice the string S, right? So 1: means give me the substring starting at the second character of S, right? And so that gives you B through G. 4 means give me the substring starting at the character at index 3, right? Going up to but not including the character at index 4, right? So that's the D, right? 5 through 7 means give me the character starting at index 5, going up to but not including the 7. So you can't slice a string using this notation in Java, but there is a substring method that does the exact same thing, right? So substring is basically the analog Python slice for strings, right? The only difference is that you can't use negative indexes, right? Instead of writing s square bracket 1 colon, right, you just write s substring 1, right? And that gives you the rest of the string starting at 1, right? Sorry, all of the characters of the string starting at index 1. Instead of writing s square bracket 3 colon 4, you write s dot substring 3 comma 4, right? And instead of writing s square bracket 5 colon 7, you write s substring 5 comma 7, right? And it behaves exactly the same way as the Python slice. If you use an invalid index, you end up with an exception being thrown. So I can show you that quickly here. So string sub equals, I don't remember what my strings are. So sub string, so I'm going to try 0 through 10. Right? I'm going to run that. Sure. So 10 is an invalid index for this string. So I have to be careful with that. So that's not exactly the case. All right. So if you run this particular, you end up with an exception being thrown. Right? It tells you you're trying to slice the string starting at 0 and ending at 10, but the length is 5, so it's not going to work. Right? So it turns out that the stopping index is allowed to be 5 in this case. Right? So that works just fine. Right? No errors. It did run. Right? So the rule here is that your indexes have to be between the range 0 and the length of the string. Right? Now you might say, hey, the length of the string, that's not a valid index for a string, and that's true. Right? But remember, how is your slice defined? Right? Or how is the slicing operation defined? Right? That value there, right, is 1 bigger than the last location in the string. Is allowed to be this location here is 1 bigger than the last index of the character that you want from the string. So you are allowed to pass in the size of the string here and here. Right? And so the 5 here is fine. Right? The 5 as a beginning index is also fine as long as the last index is also 5. Right? So the slice starting at index 5 but not including the element in index 5 has length 0. And so in this case, sub is the empty string. Right? So that's how the substring or the slice operation works. Okay, comparing strings for lexicographical order. Lexicographical means dictionary order. Right? Python's nice. You can use less than, greater than, and equals to. Right? Notice equals to. Hey, look, this is right. Everything in Python, if you want to have their equals, you use equals. Right? Which is nice. So s less than t tests if s comes before t in the dictionary. Right? So a or aardvark, z or zebra, doesn't matter which one, right? S will be less than t, that will be true. Oh, sorry. Python, big T, big F, and big T. Right? Is S greater than T? Obviously it's not. S comes before T, so not after T. So that, sorry, false. Right? And are S and T the same string? The answer, is S equal to A? The answer is true, right? So in Java, you can't use the less than and greater than operators. Right? Oh, sorry, back here. You can also use less than or equal to, greater than or equal to in Python. It works exactly the way you'd want it to. In Java, you can't use the less than and greater than operators unless you're working with primitive values. Right? String's not a primitive type, so you can't use less than and greater than. So how do you compare two strings for order? The method is compare to. Right? So S compared to T returns a negative value if S comes before T in the dictionary. Right? S compared to T returns 0 if S equals T is also true. Right? So another way to test if two strings are equal is to use s compared to t, and then check if the answer is 0. Right? So if s compared to t equals 0, the strings are also equal. Right? S compared to t returns a positive value if s comes after t in the dictionary. Right? So negative if s comes before t, positive if s comes after t, 0 if they are the same string, or if they are equal strings, sorry. Right, so here's aardvark and zebra. Right? So s compared to t, well, aardvark comes before zebra in the dictionary, so this is going to be some negative value. Right? S compared to s, so these are the same strings, so they're definitely equal. So that's going to return 0. Right? T compared to s, zebra comes after aardvark, so that's going to be a value greater than 0. The returned value tells you something about how these two strings are different. Right? If you're curious as to exactly what the returned value is, you can look at the documentation for compare to and see what it is. Right? For our purposes, we only care if it's less than 0, greater than 0, or equal to 0. So if you want an example of using that, right, we can do that quickly here. So compare to always returns an int. Compare to t, I guess. Okay, so let's go make s and t. So there's s is hello, t is, let's make t big H hello, and see what happens. And let's print out the value of compare. Okay, so we're comparing little h hello to big H hello. And Java thinks that 32. So Java thinks that little h hello comes after big H hello in the dictionary. Right? If you were to sort a bunch of strings, little h hello shows up, prints out s. Yes, little h hello comes out after big H hello. Right? I guess we can write an if statement here. So if compare is greater than 0, oh, let's do it this way. S plus, oh, sorry. S plus comes after plus t, like that. So let's use string concatenation and actually print out the strings that we're comparing. Right? And so here we get little h hello comes after big H hello. So there's how you use compare to, right? If you want to replace a character in a string, or if you want to replace a substring in a string, you can use the replace methods. So there's two of them. There's one that replaces a character, there's one that replaces a substring. So you can replace a character, so in this case p, with another character t, right? So you can replace a character with a character. You can't replace a character with a substring, right? So here you replace a single character, in every occurrence of a single character. So if we start out with sparring with a purple porpoise, I replace all the P's, you get starring with a turtle tortoise. Right? Here's hi-ho, it's off to work we go. I can replace every hi-ho with an oh no, and you get oh no, it's off to work we go. When you replace, the replacement string does not have to have the same length as the substring. Right? So instead of oh no, you could write something else. Right? It doesn't have to have the same number of characters. And it can even be empty. So you can remove occurrences of a substring using replace if you wanted to. Okay, so that's all I want to talk about for strings. I think that's more than enough to do many interesting string problems. The class does do a lot more though, right? So if you look at the documentation for string, right, you'll see there are many methods. A lot of the methods, if you look at them, they won't make any sense to you, right? So you'll look at it and you'll try to read it and there will be something there that you won't understand, which is fine, right? We haven't gotten to that part of the language yet, so you won't be able to read all of the documentation. So for example, here's something, there's a ... here, right? What the heck does that mean? Well, I haven't told you what that means yet, right? And there's some other things as well in here. But there's many methods here, and you can actually find, if you look on the internet and search for string libraries for Java, you will find additional, you'll find people have written code that provide even more methods that operate on strings, right? And so the number of problems that you might want to try to solve involving strings, well, is pretty much infinite, right? And so the language designers can't anticipate everything that you want to do, everything that you might want to do with a string. So there's a limit on the size of the, they've only included the methods that they think will be used by most programmers in the library. In the string class itself. Okay, so that ends the string lecture. Any questions about strings? All right, so we're now on to the next lecture. Why don't we just do this? Okay, so one of the learning outcomes in this course is that you learn a little bit about how floating point, so how real numbers are represented on a computer. Right? To actually learn how real numbers are stored on a computer, you pretty much need, you could do a whole course in this if you wanted to. Nobody does, but you could. Basically, the people who worked out how to represent floating point numbers on your computer, they all have PhDs. So this is not by any means a simple thing to try to teach first-year students, right? Or even grad students, right? There's a lot of subtleties to this topic. So if you want to use floating point numbers are just the real number approximations in a programming language. Right? Python has the float type. Right? Java has float and double, right? So I told you briefly about these. One of the confusing things that you have to remember if you're a Python programmer is that double is the type in Java that corresponds to Python's float. Right? So in Java, you know that all the primitive types, they occupy a fixed and finite amount of memory. Right? And therefore, it's impossible to represent every real number exactly, because real numbers can have an infinite number of digits in them. Right? The problem is, superficially, the problem is even worse than it looks. Right? So if you look at this little expression here, it looks like I'm adding 0.1, 0.1, and 0.1, right? Which mathematically is 0.3. Right? If you ask Java, does it think that is x equal to 0.3, you'll get back the answer false. They're not, in fact, equals, right? Which is strange. So here's a little program that looks at this problem in a little bit more detail. Right? So here's my 0.1, 0.1, 0.1. Here's my comparison to 0.3. There's where I print it out, right? And then what I'm going to do is I'm going to take the number 0.1, and I'm going to try to print out all of the digits that are actually in 0.1. Now, you might think it should just print out 1, but you're going to see it won't, right? Then I'm going to add 0.1 and 0.1 and print out all the digits there. I'm going to add 0.1, 0.1, 0.1, and so on and so on and so forth, right? And so if you put this into Eclipse or whatever else you're using for programming, right? That's the exact same program there, right? And you run it. Okay, so first of all, 0.1 is not equal to 0.1 plus 0.1 plus 0.1 is not equal to 0.3 as far as Java is concerned, right? So what is the value of 0.1? So when you print it out, you get this, you get all that, which is clearly not 0.1. It's 0.1 and a little bit. If I add these two values, if I add 0.1 to 0.1, right, is it 0.2? And the answer is, well, no, it's definitely not 0.2. It's 0.2 and a little bit, right? 0.1 plus 0.1 is not 0.3. It's 0.3 plus a little bit, right? If I add 0.1 4 times, it's 0.4 plus a little bit. But if I add 0.1 5 times, it's exactly 0.5, which seems strange. It gets weirder, right? What is the value of 0.3? It's in fact 0.2999999 something. So it's not exactly equal to 0.3 either, right? And so that all seems strange to most people when they see this the first time, right? Why is 0.1 plus 0.1 not 0.2, right? It seems like a simple problem, right? This is true if you did this in Python as well. Python uses the exact same representation for its float type that Java uses for double. Okay, so the output that I just showed you is a little bit misleading, right? So if you look at this output and you might say, hey, look, he just showed me these floating point numbers have like a bazillion digits in them. I don't know, there's something like 40 or 50 digits here, right? And so it turns out that's not true, right? On any computer running Java, right, if you were to write down a floating point number in base 10, right, you can only actually write somewhere between 15 and 17 digits before the number doesn't change anymore, regardless of the extra digits that you add. Right? So in other words, you only really have 15 to 17 significant digits in a double value, in base 10. Right? Now that program printed out way more than 17 digits. You might ask, so why did it print out more than 17 digits? Right? And so the answer is you have to remember your computer isn't working in base 10. It's working in base 2. So what's actually happening is, right, it's working in binary. So what happens is that 0.1, which is in base 10, right, it gets converted to the nearest double value that your computer can represent. So that's in base 2, right? When I print it out, all of its digits, what the computer has to do is it has to convert the base 2 number back to base 10. So when it does that conversion, it can compute more than 15 to 17 significant digits, right? Which is why it prints out many more digits, right? Underneath the hood, though, you really only have between 15 and 17 significant digits. Okay, so what's going on? So what's going on is that almost every modern computer uses this thing up here to represent double values. To represent floating point values. So there's a standard called IEEE 754. So IEEE is the Institute of Electronic Engineers and something. I can't remember what it is. Electrical Engineers and something. So they're just they are a body that, among other things, defines standards for technical things. Right? So one of the standards that they defined was the standard for floating point arithmetic. Right? And so that's the standard that's used in most modern things that look like a modern computer. Right? So your desktop computer, your cell phone, your tablet. Underneath the hood, the CPU and all of those will follow the IEEE 754 standard. So the details of the standard are very, very, very far beyond the scope of this course. Right? It was written by a bunch of people who spent much of their lives figuring out how to do binary arithmetic on a computer. Right? So they are very highly specialized people. They have very highly specialized knowledge. So what you do need to know, though, is that the standard says when every floating point value should have this, will have this form. Right? So on your computer, every floating point value is some integer, so that's s, right? Plus or minus, so we can have negative values, which is nice. Right? So some integer times 2 raised to some integer exponent. Right? So everything is an integer times 2 raised to some integer exponent. You might ask, how do you get values that have a decimal point in it? Right? That e can be negative. Right? So it's divided by 2 to some exponent. Right? So s is called the significand, e is called the exponent. They're both integers. So why can't you represent 0.1 exactly? Right? And it turns out it's because of the way that the standard is defined. Right? So you can easily prove that 0.1 cannot be represented exactly as s times 2 to the e, and you do it by contradiction. Right? So you've all taken one of your, you've all taken CISC, I can't remember, 101 or 102 or something like that, right? Or some course where you've done some mathematical proofs, right? So you should know what a proof by contradiction is by now, I hope, right? So it's pretty straightforward, though, in this case, right? I'm going to assume s times 2 to the e is, in fact, equals 0.1 for some integer value s and some integer value e, right? E, of course, in this case must be negative, otherwise I can't get a value less than 1, right? So in other words, I have to take s and divide it by 2 to some exponent to get 0.1. Okay, so what happens? All right, so I don't want to work with 0.1. I would like to work with integer values only, right? And that's because I know that s and e both have to be integers. So I can clear the 0.1 very easily. I just multiply both sides by 10, right? So 10s times 2 to the e is equal to 1, right? I can now move the e over to the right-hand side of the equation. I just divide both sides by 2 to the e, right? Okay, so 1 over 2 to the e is just 2 to the minus e. Now remember, e is negative, so this exponent here is actually positive now, right? And I now have the expression 10s equals 2 raised to some positive exponent, right? What is 10 equal to? And 10 is equal to 2 times 5, right? What is 2 to the e equal to? Sorry, what is 2 to the negative equal to? It's 2 times 2 times 2 times 2 e times, right? Or negative e times, right? Right-hand side is made up of all prime numbers, right? Left-hand side has a 5 in it, which is also prime, right? Therefore, the prime factorization of the left-hand side cannot be equal to the prime factorization of the right-hand side, right? There's no way for me to write 5 as some product of 2's, right? And therefore, it's a contradiction, right? You can't actually write down 0.1 in the form s times 2 to the e. Right? Okay, that's a good place to stop. So before we talk about how I'm going to show you these numbers in the lecture, we'll save that for the next lecture.